Hi, my name is Bintu and today I am going to teach you how to create a single linked list in C programming. Data structures is a very important topic nowadays. It has a very deep concept of creating a linked list, doubly linked list, trees, sorting, merging, and it helps a lot in creating even compilers. The question is that why shall I go for creating a single linked list? Suppose you create an array. The problem with the array is here memories are located statically. Like for example, this A is of 5 elements. While doing programming, you determine that you need more elements beside this 5. You want more elements to store in an array. You won't be able to allocate more memory for this array because once it is allocated, you can't add more elements. You can't resize it. Secondly, while programming, you feel that you need only 2 elements of array. You cannot again free that 3 extra elements which has been booked, which you don't want. So the problem with static memory allocation is that once the memory is allocated, it can't be resized, it can't be reduced even. This linked list is the concept of dynamic memory allocation. When a node, this is a node, has 2 pointers, it is known as doubly linked list or 2 directional linked list. This is a single directional. It has a pointer pointing to only one node. Here you can see that if you want to add one more node, you have to simply allocate more memory and you have to just get it attached to the existing nodes. That's it. For example, you want to insert any element in between 2 to 8. Create a new node, set the pointer of this node to point at that node and set the pointer of the new node to point at this node. That's it. So that new node will be inserted between 2 and 8. Dynamic memory allocation is a technique of memory optimization. You can free the memory once your job is done. You can allocate more memory, so it will use the memory optimistically. So I'm beginning with my lecture. This is the code for creating and displaying single linked list. You can see that you need a structure. I am just creating a single linked list which comprises of only integer values. You can have strings also. You can have float values. You can have more than one data member. You can have a string, integer, float combined into a node. Defining here a structure node which consists of 2 data members. One is to store integer value. Second data member is known as next. I can have any name and it points to the structure type node. This next is just to point at another node. That's it. It is just for linking another node. You are defining one global pointer start list. This start list will be used to point at the first node because obviously after creating a linked list you want to traverse its element. It is through the start list pointer that you will be traversing the entire linked list. You are defining it globally of type node. These are the 2 prototypes of the 2 methods that we are going to use in the program. One is for creating a linked list. Second is for displaying the linked list. You are initializing the start list to null because initially the linked list has to be empty. Here's the function that creates a linked list. First of all, you allocate the memory for the new node. Obviously it will have 2 data members. One is for data and another pointer. The pointer will point at null initially and you will ask the user to enter the value for this data member. Suppose the user enters 5. That will be assigned to the data member of this new node. Thereafter, you will ask the start list to point at this new node because start list, as I said, is used for assessing, is for traversing the entire linked list. After that, you use another pointer temp to point at this new node because it is through the temp that you will be connecting the other nodes. So initially, the 3 pointers are pointing at this new node. Thereafter, you will ask the user, do you want to add more? Suppose the user enters yes. You will allocate the memory for the new node. Then new node pointer will not point at this structure. It will point at the new node. You will ask the user to enter the value for this new node. Suppose the user enters 2, which will be assigned to the data member of this structure. After that, you will ask this next pointer of temp to point at this new node to connect them. So this next pointer is pointing at the new node. So these 2 nodes are connected. Thereafter, you will ask the temp to point at this new node. Why is it so? Because obviously you want this temp to be used for connecting to the 3rd node and so on. The purpose of the temp pointer is just to point at the previous node so that it can connect to the next node. And start list pointer will remain fixed at the first node because that is used only for traversing the linked list. Again, you will ask the user, do you want to add more? Suppose the user enters yes. The memory will be allocated for the new node. User is prompted for the next integer. Next pointer of the new node is always set to null. Thereafter, the next pointer of temp, which is just pointing at the previous node, is set to point at this new node. Hence, this is connected. Thereafter, temp is asked to point at the new node. This will keep on continuing for the time the user enters yes. Let's understand the code. K is initialized as y. This loop will execute for the time that user enters lowercase y or uppercase y. Start list was initialized to null. This is the if block while adding the first node of the linked list. There are two methods in C for allocating memory. One is malloc and another is calloc. Malloc is used for allocating a single block and calloc is used for allocating multiple blocks. So what is this method doing? It is allocating this number of bytes. Syzor will find the number of bytes required by the node structure. That much number of bytes is allocated and that memory will be used by the pointer of type node. And that memory, that whole block is pointed to by new node, or that whole block is assigned to new node. So by this statement, the new node is created. You are asking the user to enter an integer value. Suppose user enters say 5. That will be assigned to the data member of new node. The next member of new node is set to null. Start list pointer is set to point at new node. Temp is set to point at start list node. This thing. Because if block is executed, control will never go to else. It will ask the user, do you want to add more? Suppose user enters y. See, here is a space. Be careful while entering a single character. It's a single byte, right? After pressing y, obviously you will press enter key. That enter key is also a byte. That enter key will be assigned to the next execution of k. So it won't stop to ask you for the successive execution. So this blank space is for absorbing that extra enter key. So do you want to add more? Suppose the user enters y, it will go here. Is start list null? No. Now start list is pointing to some node. It will come over here. Next node is allocated. Asking the integer value for the next node. User enters suppose 2, that will be assigned to the data member of the new node. Next pointer is set to null. Then the next pointer of temp, which is pointing to just previous node, is set to point at the new node. So they are connected. Then temp is set to come and point at the new node. So temp will come and point at the new node. Want to add more? Suppose you say yes. Control will not go into if block. It will come here. New node is allocated. Integer value is asked for the new node. Here the value is entered. Suppose say 8. Next member of new node is set to null. The next member of temp is set to point at the new node. See how it is connected. Thereafter temp is asked to come and point at the new node. See. So you must have followed that temp is just to point at the previous node so that it can help in connecting the new nodes. And start list is still set to point at the first node only. This display link list, which is executed once the user enters no, it will exit from the while loop. Here what you are doing, you are making use of the temp pointer. You are setting it to point at the first node, start list. If temp is not null, if temp is null, it will display the message that linked list is empty. But if the temp is not null, it will print the message, the content in the linked list are, while temp is not equal to null, until unless temp becomes null, this loop will execute. It will print the data member of temp, that is the first element of the linked list. Temp is asked to move and point where its next member is pointing. So obviously temp will move and point to its successive node. The while loop execute. Is temp null? No, it is not yet reached to the null at the end of the linked list. So it will print the next element. It will print the data member of the next node, move on to the next node. This statement will always make temp to point at its successive node. It will keep on pointing, it will keep on moving to the node where its next pointer member is pointing. So this will keep on executing unless the temp reaches null where the linked list terminates, where the linked list is over. Let's run it. I am using Unix to execute my C programs and I am using Kigwin for that. Kigwin is a software package which gives you an environment to run Unix programs on Windows. This is the program that I have already typed for you in Unix. See, this is that. Let's compile it. I am using GCC compiler to compile. No message, that means the program is compiled successfully. I am running it. Enter value yes. 5. Want to add more? Yes. Next value say 2. Want to add more? Yes. Say 8. Want to add more? No. So this is that. It has displayed all the values. So the program is working perfectly. If you find any problem or you want the code for this program, please mail me at bmharwani@yahoo.com. If you want to see more of my video tutorials, this is my channel on YouTube. Please visit this, and do not forget to subscribe me and also write comments. Please guide me what are the topics that you want me to create tutorials on. Comments are heavily required. Thank you so much. Have a nice day.